Have you ever noticed those little black and white squares popping up everywhere? They're on your takeout menu, on the back of a bus, on your concert ticket, and maybe even on a banana. These aren't just random modern art, they are QR codes, which stands for Quick Response Code. Think of them as a secret doorway, a special key that unlocks a hidden digital world using a device you probably have right in your pocket, your smartphone. They are designed to be read incredibly fast, connecting the physical things you see and touch with the vast, amazing world of information, videos, and websites on the internet. It's science in action, hiding in plain sight. These codes are like a super-powered version of the old-school barcodes you see on groceries, those simple lines that cashiers scan. But while a traditional barcode can only hold a tiny bit of information, like a product number, a QR code can hold so much more. It can store a website address, a Wi-Fi password, your contact information, or even a whole paragraph of text. This ability to hold lots of data is what makes them so versatile and useful in our daily lives. They are a simple, elegant solution for sharing information without having to type in long, complicated web addresses or phone numbers. It's all about making life a little bit easier and a little more connected. You see them in restaurants, where a quick scan can bring up the entire menu right on your phone, reducing the need for paper menus. You find them in museums, placed next to an exhibit, ready to whisk you away to a video explaining the history of an ancient artifact. They are on packages, letting you track your delivery in real time. This seamless connection between an object in front of you and a universe of digital content is what makes QR codes so powerful. They are a simple visual tool that bridges two different worlds, and they do it with a level of efficiency that is truly remarkable. The beauty of the QR code is its simplicity for the user. You don't need any fancy, expensive equipment, you just need your phone's camera. Point, scan, and you're there. This accessibility has made them a universal tool, understood and used by people all over the globe, regardless of language or technical skill. They are a quiet, unassuming piece of technology, but they have fundamentally changed how we interact with information in public spaces. They've turned our entire world into an interactive experience, where every poster, product, or sign has the potential to tell you more. Consider this. Let's take a closer look at that little square. It might seem like a random jumble of black and white boxes, but every single piece has a purpose. It's a highly organized system. The entire grid is made up of tiny squares called modules. The way these black and white modules are arranged is the code itself, like a secret language written in pixels. In the corners you'll almost always see three large identical squares. These are the finder patterns. They are the anchors of the code, telling the scanner exactly where the QR code is and which way it's oriented. This helps your phone's camera lock on instantly, even if the code is tilted or upside down. It's a brilliant bit of engineering. Beyond the three big finder patterns, there are other important markers. You might notice a smaller square called an alignment pattern, tucked somewhere inside the grid. For larger, more complex QR codes, this extra pattern helps the scanner figure out if the code is on a curved surface or slightly distorted. Think of it as an extra guidepost that helps the software straighten out the image before reading the data. There are also timing patterns, which are lines of alternating black and white modules that run between the big finder patterns. These act like a ruler, telling the scanner the exact size of each individual module so it can read the grid accurately. All the other little black and white squares, the modules, are where the actual information is stored. This is the data zone. Each module represents a bit of information, which is the fundamental unit of data in computing. In the simplest terms, a white square might represent a 0 and a black square might represent a 1. By arranging these zeros and ones in a specific sequence, the QR code can spell out words, numbers, and symbols that form a web address, a text message, or any other piece of data. It's a binary language, the same one computers use, but presented in a visual format that a camera can read. The system is incredibly efficient at packing information into a small space. The more information you need to store, the more modules are added, and the denser the QR code becomes. A simple code for a short website link might have a small grid, while a code containing a digital business card with your name, phone number, and email will have a much more complex pattern with many more tiny squares. It's a scalable system, designed to be as compact or as expansive as it needs to be. Every single dot has its place in this intricate digital puzzle box, working together to deliver a message in the blink of an eye. So, how does your phone or a scanner read this pixelated puzzle so fast? It's a beautiful multi-step process that happens almost instantaneously. When you open your camera app and point it at a QR code, the first thing your phone's software does is look for those 3 big finder patterns in the corners. These patterns are unique and don't look like anything else, so the software can spot them immediately in the camera's field of view. Once it locks onto these 3 corners, it knows it has found a QR code and can isolate the entire square from the background, whether it's on a poster, a box, or a t-shirt. It's like spotting a target. Once the software has identified the boundaries of the code using the finder patterns, it gets to work correcting the image. The world isn't perfect. You might be holding your phone at an angle, the QR code might be printed on a wrinkled piece of paper, or the lighting might be a little dim. The software uses the finder and alignment patterns as reference points to digitally flatten and reorient the image. It stretches and warps the picture of the code until it looks like a perfect, flat square. This step is crucial because the software needs a clean, undistorted grid to read the data modules accurately. It's like straightening a crumpled piece of paper before you read it. Now that the software has a clean grid, it can start reading the data. It overlays a digital grid on top of the corrected image, using the timing patterns to make sure everything lines up perfectly. Then, it goes through the grid, one module at a time, and determines if each tiny square is black or white. It converts this visual pattern into a long string of binary data, those ones and zeros we talked about. A black module becomes one number, and a white module becomes the other. The result is a stream of raw digital information that represents everything that was encoded in the pattern. The final step is decoding that binary string. The QR code contains information not just about the data itself, but also about how that data was encoded. The software reads this information first, then uses it to translate the string of ones and zeros back into something humans can understand. It could become the letters https:// to form a website URL, or the numbers of a phone number, or the text of a message. Once decoded, your phone's operating system takes over, asking if you want to open the link in a browser, save the contact, or connect to the Wi-Fi network. It's a symphony of optics, geometry, and software, all happening in less than a second. One of the most brilliant features of a QR code is something you can't even see: its toughness. I'm talking about error correction. Think about where you see QR codes: on a coffee cup that gets smudged, a poster that gets torn, or a sign that's been faded by the sun. If a tiny part of a regular barcode gets damaged, it often becomes completely unreadable. But QR codes were designed from the very beginning to be resilient. They have a built-in backup system that allows them to work even when a part of the code is missing or obscured. It's an incredible feat of data engineering that makes them so reliable in the real world. This magic is possible because the information in the code is stored with a lot of redundancy. When the QR code is created, the data is mixed with special error correction code words. These are extra bits of data that are mathematically related to the original information. It's kind of like sending a message, but also including a bunch of clever clues about what the message says. If part of the message gets lost or scrambled, the scanner can use these clues to figure out what the missing pieces were supposed to be. It can literally rebuild the damaged data and read the code successfully. There are actually different levels of error correction you can choose from when creating a QR code. The lowest level can recover about 7% of damaged data. The highest level can withstand up to 30% of the code being unreadable. This is why you sometimes see QR codes with a logo or a picture right in the middle of them. The logo covers up some of the data modules, but because the error correction is set to a high level, the scanner can still read the surrounding modules and use the redundant data to fill in the blanks. The code sacrifices some of its data capacity for this robustness, but it's a worthwhile trade-off for reliability. This built-in resilience is a key reason why QR codes have become so widespread. They don't need to be in pristine condition to function. They can handle the wear and tear of everyday life. A little scratch, a bit of dirt, or a splash of water won't stop them from doing their job. This makes them perfect for industrial settings, outdoor advertising, and fast-paced retail environments where things aren't always perfect. It's a technology that was designed not for a sterile lab, but for the messy, unpredictable, and beautiful world we all live in. That's some smart science. To really appreciate the QR code, we have to take a quick trip back in time. Our story begins in 1994 in Japan. A company called Denso Wave, a subsidiary of Toyota, was looking for a better way to track automobile parts during the manufacturing process. The traditional barcodes they were using just couldn't hold enough information, and their workers had to scan multiple barcodes for a single component, which was slow and inefficient. An engineering team, led by a man named Masahiro Hara, was tasked with creating a new type of code that could hold more data and be scanned much, much faster. The team worked tirelessly to develop a solution. They studied how to encode different types of characters, including Japanese kanji and kana, into a compact, two-dimensional format. Their breakthrough was the unique finder pattern, those 3 squares in the corners. They discovered that this 1:1 to 3:1 ratio of black to white to black to white to black pixels was the least common pattern found in business forms and other printed materials, which meant a scanner could pick it out from its surroundings with incredible speed and accuracy. After much experimentation, the quick response code was born, capable of being read from any angle and storing hundreds of times more information than its linear predecessor. What Denso Wave did next was truly remarkable, and is a huge reason for the QR code's success today. Instead of keeping their invention proprietary and charging licensing fees, they made the specification public and patent-free. They wanted everyone to be able to use it. This open-source approach allowed the technology to spread across different industries in Japan, especially in manufacturing and logistics, where its speed and data capacity were a huge advantage. For many years, however, it remained a niche technology, a powerful tool used mostly behind the scenes, away from the public eye. The QR code's big moment on the world stage came much later, with the rise of the smartphone. But its true explosion in popularity was driven by an unexpected global event, the COVID-19 pandemic. Suddenly everyone needed a way to share information without physical contact. Restaurants replaced physical menus with QR codes on tables. Businesses used them for contact tracing check-ins. Public transit systems used them for contactless ticketing. The pandemic forced the world to adopt this 25-year-old technology on a massive scale. And people quickly realized how simple and powerful it was. It went from an industrial tool to an everyday essential, almost overnight. Today it feels like QR codes are simply everywhere, and for good reason. They have moved far beyond their original purpose of tracking car parts, and have integrated themselves into nearly every facet of our daily lives. One of the most common places you'll find them is in the world of dining and hospitality. As we saw during the pandemic, restaurants embraced QR codes for contactless menus. This was not just a temporary fix. Many establishments have kept them because they are easy to update with daily specials, reduce printing costs, and offer a more interactive experience for customers. It's a simple, hygienic, and efficient solution. The world of payments and finance has also been transformed by these little squares. In many parts of the world, QR code payments are now a standard way to do business. You can scan a code at a farmer's market stall to pay for your vegetables, or at a checkout counter to complete your purchase, all without needing to pull out a credit card. These systems link directly to your mobile wallet or banking app, providing a secure and incredibly fast transaction. They have democratized digital payments, making it easy for even the smallest businesses to accept electronic money without needing expensive card-reading hardware. Think about travel and entertainment. Your airline boarding pass is now often a QR code on your phone, which gets you through security and onto the plane with a quick scan. Your ticket to a concert or a movie is no longer a paper stub, but a digital code that grants you entry. This shift has made ticketing more secure, as codes can be uniquely generated and tracked, reducing fraud. It also adds a layer of convenience. You no longer have to worry about losing a physical ticket, as long as you have your phone. It streamlines the whole process, getting you to the fun part faster. Furthermore, QR codes have become a vital tool in marketing and information sharing. You'll find them on product packaging, linking you to instructions, recipes, or information about the product's origin. They appear on real estate signs offering a virtual tour of a house. They are used in museums to provide audio guides and on business cards to instantly save contact information. Each code is an invitation to engage further, to learn more, and to connect with a brand or service on a deeper level. From the factory to the food court, the QR code has become an indispensable and versatile tool of the modern world. When you stop and think about it, a QR code is more than just a box of pixels. It's a bridge. It is one of the most effective and elegant technologies we have for connecting the physical world we inhabit with the vast, interconnected digital universe. For decades, these two realms were largely separate. Information online was stuck online, and information in the real world was stuck in the real world. The QR code acts as a simple, intuitive portal between them. It turns any object, poster, or place into a potential hyperlink, making our surroundings interactive and rich with information. This is, in my opinion, its most profound contribution. This role as a bridge is only going to become more important as technology evolves. The future of QR codes is incredibly exciting and extends far beyond just opening a website. For example, consider the world of augmented reality, or AR. Imagine pointing your phone at a QR code on a box of Legos, and a three-dimensional animated model of the finished creation pops up on your screen, which you can rotate and inspect. Or scanning a code in a history book to see a historical figure come to life and deliver a famous speech. QR codes can serve as the perfect trigger to launch these immersive AR experiences, blending digital content with our physical reality in a seamless way. The world of secure transactions will also continue to be shaped by this technology. We are already seeing QR codes used for more than just simple payments. They are being integrated into systems for secure identity verification, for accessing secure buildings, or for pairing new devices to your home network without typing in complex passwords. As encryption and security technologies improve, the QR code will become an even more trusted vehicle for exchanging sensitive information safely and instantly. It's a simple interface for very complex and powerful digital actions, and that simplicity is its strength. In conclusion, the humble QR code is one of the unsung heroes of our digital age. From its clever design with built-in error correction to its journey from a Japanese factory to a global phenomenon, it has proven to be a remarkably resilient and useful invention. It empowers us to connect, to learn, and to interact with the world in a richer, deeper way. As we move forward, this simple black and white square will continue to be a key that unlocks new possibilities, from augmented reality to the next generation of digital payments. So the next time you scan one, take a moment to appreciate the science. It's a small square, but it's building a big, connected future. Consider that.